In November 2024, a rare and unanticipated underwater volcanic eruption began at the imposing AIC Mount, a gigantic seafloor volcano located close to the Mariana Trench, the Earth's deepest known point. This geological upheaval triggered a series of remarkable events, including extensive clouds of discolored ocean water and possibly floating pumice which drifted across the surface of the sea. Recognizing the intensifying geological unrest, the Northern Mariana Islands Volcano Observatory promptly elevated the volcano's alert status to advisory and changed the aviation color code to yellow, signaling a notable surge in volcanic activity with potential regional impacts. Though the isolated position of AIC Mount limits immediate threats to populated areas, the event underscores the vast and hidden geological processes continuously active beneath the ocean in one of the world's most tectonically dynamic areas. AIC Mount is a massive undersea volcano that rises dramatically from the ocean floor, located roughly 18 kilometers southeast of Farallon de Pajaros in the northern Mariana Islands. Despite its towering height, the volcano's summit remains approximately 75 meters below sea level, concealing its full magnitude beneath the waves. It is part of the Mariana Volcanic Arc, a highly active chain of islands and submarine volcanoes. Stretching across the western Pacific Ocean, this region's volcanic activity is driven by the subduction of the Pacific Plate beneath the Philippine Sea Plate, a major geological process that releases water and gases from the descending slab, reducing the mantle's melting point and generating magma that eventually rises to form volcanoes like AIC Mount. The eruption, which officially began in August 2024, has drawn growing scientific interest due to its scale and potential implications. Researchers and geologists are employing sophisticated satellite imaging and underwater hydrophones to observe the volcano's activity. These hydrophones, designed to pick up acoustic waves produced by underwater volcanic activity, have not yet registered substantial signals, highlighting the challenges in studying submarine eruptions. Unlike land-based volcanoes, underwater eruptions often generate large plumes without producing distinct sound signatures, making visual and satellite data crucial for tracking their evolution. Despite modern advancements, monitoring submarine volcanoes remains a significant challenge due to their remote locations and lack of nearby seismic sensors. Scientists must rely on indirect indicators such as shifts in water coloration, thermal anomalies, and the appearance of floating pumice or gas bubbles. AIC Mount's continued unrest demonstrates the complexities of studying submarine eruptions, which lack the extensive monitoring networks and direct observation possible for terrestrial volcanoes. Consequently, remote sensing technologies are essential to detect even minor environmental changes, helping scientists evaluate hazards and understand the ever-changing nature of underwater volcanic behavior. Although AIC Mount's isolated position reduces the immediate risk to coastal populations, its eruptions pose hazards to marine navigation as floating volcanic debris can damage ships and interrupt sea travel. Mariners near the area are urged to remain vigilant as past eruptions have illustrated the unpredictable nature of volcanic events in this region. Historical records indicate that AIC Mount has experienced several major eruptions that have reshaped its structure. Noteworthy events occurred in 1979 and 2001, both significantly altering the morphology of the seamount. During the 1979 eruption, a fishing crew reported feeling intense vibrations near the summit, followed by a surge of sulfur-rich water indicating increased volcanic activity. The 2001 event was detected via seismic activity recorded hundreds of kilometers away, underscoring the importance of remote monitoring for submarine volcanoes. A more recent eruption in 2014 created a new summit crater and triggered a landslide on the volcano's southeastern flank, transforming its physical structure and showcasing the raw force of underwater volcanic energy. Between October 2022 and May 2023, AIC Mount remained active through several eruptive phases, with another episode of increased activity occurring between December 2023 and April 2024. These patterns affirm its status as a highly active volcanic feature that requires constant observation. AIC Mount's geological context is shaped by a complex interaction of subduction processes and back-arc basin spreading, which contribute to its frequent eruptions. These dynamic forces lead to ongoing magma production, which sporadically erupts onto the seafloor, gradually layering volcanic rock and enlarging the seamount. Although AIC Mount has yet to break the ocean surface to form an island, its persistent activity suggests that it might one day emerge above sea level, representing a significant geological development. The volcano structure is in a continual state of change. Its summit features a crater formed by explosive eruptions, and its steep sides bear signs of landslides triggered by unstable volcanic deposits and tectonic shifts. Rapid accumulation of volcanic materials can make these steep flanks highly unstable, causing structural alterations that reshape the seafloor over time. The nearby Back-Arc Basin plays a vital role in feeding magma to AIC Mount through seafloor spreading, fueling ongoing volcanic activity. Despite its distance from populated areas, AIC Mount's eruptions provide essential insight into submarine volcanism and the broader geological dynamics within subduction zones. These ongoing events present scientists with a rare opportunity to explore the intricate processes that influence the Earth's crust and emphasize the importance of understanding such phenomena to manage potential risks. While AIC Mount's eruptions are unlikely to directly trigger other volcanic events within the Pacific Ring of Fire, the possibility of indirect effects cannot be entirely dismissed. Large eruptions or accompanying tectonic activity, such as significant earthquakes, can shift regional stress patterns in the Earth's crust, potentially affecting nearby geological systems. However, such interactions are usually limited to adjacent areas and are relatively rare. One phenomenon, known as dynamic triggering, occurs when seismic waves from a powerful eruption or quake disturb other volcanic systems. For this to happen, the affected volcano's magma chamber must already be under substantial pressure and nearing eruption, meaning dynamic triggering acts more as a contributing factor rather than a sole cause of distant volcanic activity. Compared to other well-known submarine volcanoes like Hunga Tonga Hunga Ha'apai, AIC Mount displays different eruption behaviors, environmental effects, and geological traits. Though both volcanoes are part of the Pacific Ocean's vast and turbulent volcanic environment, their distinct characteristics and histories highlight the incredible diversity of submarine volcanism. The frequent eruptions and transformative changes at AIC Mount underscore the dynamic nature of Earth's undersea landscapes, giving scientists a rare window into the powerful geological forces shaping our planet. The November 2024 eruption of AIC Mount near the Mariana Trench stands as a vivid reminder of the vast, mostly unexplored volcanic activity beneath the ocean surface. As a critical component of the Mariana volcanic arc, AIC Mount continues to intrigue scientists with its evolving behavior and immense geological influence. The eruption, which began in August, has produced plumes of discolored water and floating pumice, clear signs of ongoing volcanic action that remain difficult to track and fully interpret. AIC Mount's significance goes far beyond its current unrest. Its location in one of the world's most geologically active zones ensures that it will remain central to our study of submarine volcanism for many years to come.